Good day to you and welcome to Physics with Paulamin. Basically, where physics is made easy. Yeah, you are in the right place. Physics is made easier and beautifully. It is the WAEC season and WAEC practicals is just but 6 days from today. All right. Some days ago, the specimen and apparatus were released, and this has thrown the academic community into some bit of dilemma as per what is WAEC driving out the season with their apparatus that they are demanding, with the specimen that they have put out. WAEC is trying to cut down on that prediction ability of most teachers and most students around. All right, but today we are going to be looking at the question one, which falls under mechanics of the specimens released by WAEC. All right, so we have these apparatus. 2 meter stand has been demanded, thread, 2 identical spiral springs, a meter rule, masses of units 150 grams, 200, 250, so on, up to 350 grams, and a stopwatch also, an optical pin, plasticine, pendulum bulb, 2 screws of uniform thread. Now, from these listed specimens, we can actually get up to four experiments. We can actually predict up to 4 experiments from this. All right. So before I start our prediction this day, I want you to quickly do something for me. If you haven't done it, all right. So I will need you to go to the profile section and do well to subscribe to this channel. Do well to subscribe to this channel. It's absolutely free. This apparatus given can actually fall under either simple harmonic motion or Hooke's law. Simple harmonic motion or Hooke's law, and we'll delve in with the first of 4 experiments WAEC may put out there. Remember, we do not aid or rather carry out anything malpractice on this channel. All we do here is to prepare your mind, is to create a level of preparation. Okay, that's what we do here with Physics with Paulamin. All right, so let's see the first experiment. This experiment actually puts 2 things together: Hooke's law as well as simple harmonic motion. Hooke's law as well as simple harmonic motion, like was demanded in the apparatus in the specimen section, will require 2 meter stand. All right, so you will need to get 2 meter stand and place them in this form. Place them in this form facing each other. Place them in this form. 2 meter stand. We also need to get a thread. The thread will be used to form a loop with the tip of our spiral springs, and then 2 identical spiral springs. 2 identical spiral springs must be provided. I think the reason for this is because 2 identical spiral springs will definitely have the same force constant. All right, so achieve an amount of accuracy in our readings, we will need 2 identical spiral springs. Their K values have to be the same, so that's why it was demanded. It was demanded there. Then we need a meter rule. As you can see, our meter rule was connected to the spiral springs and left or placed in an horizontal orientation. Okay, and different masses: 150 grams, 200 grams, 250 grams, so on and so forth. These grams, according to what we have here, they'll be placed at the midsection of this meter rule. They'll be placed in the midsection of this meter rule. Do not forget that at the center of a meter rule is where the meter rule's center of gravity is, where the mass and weight is concentrated. So it is important that these masses, they are placed at the midpoint. We'll also be requiring a stopwatch. Now you may ask, what is a stopwatch needed for in these experiments? That is because I think I'm actually going to explain that much later. Okay, but that is because we'll be displacing this meter rule vertically. We'll displace it downwards a bit and observe it do some amount of cycles, some amount of oscillations, and probably calculate the period from there. All right, so that is why a stopwatch is required. Plasticine, well, masking tape can also play the role of the plasticine. Also not visible here, not required here, except for cases where we will need to tape masses to the meter rule, and also need to tape this loop so that it does not tumble. Okay, so we may require a plasticine or a masking tape at this point. A pendulum bulb, well, there's no pendulum bulb in this particular setup. Like I said earlier, WAEC can be very good with putting things that you may not need for that experiment. So but this pendulum bob can come in the subsequent experiment also from this question 1. Then we have 2 screws of uniform thread. Very important. These 2 screws of uniform thread can be applied here anyways, just that we are trying not to destroy our equipment, apparatus in the process of carrying out this experiment. I could also use these 2 screws here, all right, and hang the thread on the screw. Okay, it means that I will have to screw my meter room. Okay, so we are trying to see how we can avoid destroying the apparatus in the process. Okay, so the 2 screws can also be replaced for this loop formed. Okay, maybe when we are doing the practical, I'm currently not in the lab right now, so maybe when we're doing the practical, we may just use the screw. All right, but this is what is required generally, and that is what we use to form this particular assembly. Not too difficult to set up. It's not really difficult to set up actually. You just need to find and support your spring from your clamp. Right, you need to support your spring from the top of the clamp. You need to hold it, form a rigid support for your spring. To the other end of your spring, you need to apply a thread. You need to attach a thread rather. And since the expectation is that this spring should be hanging vertically, perfectly vertical, we need to make sure that the length of the thread here is the same as the length of the thread here. Okay, the length of the thread here should be the same as the length of the thread here. What would that bring for us? If the thread here is not the same as this, the length is not the same as this, we'll observe that our meter rule may be slanting. It will not be perfectly horizontal. All right, and for us to achieve accurate results in this experiment, we need this meter rule to be standing or to be oriented perfectly horizontal. Okay, so to achieve that, the length of thread here should be equal to the length of thread at this point. Okay, so we'll place our meter rule into that loop, and also based on the questions, I don't know, this is just a prediction, okay, but I'm very sure that it will come out in this form. So where are you going to put the loop? That may be indicated in the question on that day. All right, so we can just say, let's put that at 10 here and 90. All right, so that the distance between the loop should be 80. Okay, so it depends on the question you are being asked, the place you are asked to place it. All right, then after doing that, basically you are actually done. You're actually done just to perform the experiment. Let me just give a theoretical perspective to how this experiment can be performed. We're still going to do it in the laboratory. Like I said earlier, currently I am not in the laboratory, okay, but we'll see that video soon enough at the actual practical video. So I'm going to take my mass. The first mass given here is 150 grams, and I'm going to place that 150 gram mass at the midsection of the meter rule, which will likely be the 50 centimeter mark. I'll place it there, and then I'll use my plasticine or my masking tape to taper it so that it doesn't fall off during the vertical motion, during the vertical displacement. So after taping it to the meter rule, I will balance this enough. I'll balance it, make sure that it is not oscillating. All right, make sure that it is not oscillating. So before I'm going to carry out this experiment, the instruction should be given that, okay, displace this assembly vertically downwards, just displace it vertically downwards, and observe the time taken to perform a number of oscillation, and observe the time taken to observe a number of of oscillation. And you know that the time taken to perform a number of oscillation is the period. All right, and period is number of oscillation, which I'm going to represent, the time taken, which I'm going to represent with time t over number of oscillation. Okay, so I'm going to observe after displacing downwards, it will go one, so it will go up, down, that is 1, it goes up, down again, that is 2. All right, so I'm going to be giving a number of oscillation to calculate number of oscillation. So what time it will take to perform a number of oscillations? They can say what time will it take to perform, let's say 10 oscillation or maybe 20 oscillations. All right, so for every time you displace this down, you count 20 oscillations and use your stopwatch to look out for the time it will take to perform 20 or maybe 10 oscillations. After doing that, you need to record. Actually, when we're doing the actual practical, I'll give us the table of values, okay, the headings of the table of values. Okay, so you will need to write down. Let me just show you something here. So let's say for mass is measured in grams, okay, and we have for time, I'm going to take this time reading 2 times for accuracy to reduce error, okay, and then I'm going to get my period on this column. Like I said, we are still going to perform this experiment, okay. So for the first mass, that is 150 grams, 150, let me say 0.00, okay. After running this for 20 oscillations, I'm going to take note of the time it will use to perform that 20 oscillations. I'm going to do the first one. Sorry, my marker is off. I'm going to do the first one, then do it again, then take the mean of these 2 values and get the actual value. All right, so I'll perform 20 oscillations, or maybe 10 oscillations for 150 grams, okay, and get the time for that 20 oscillation. Let's say it is 10.5. That's my first attempt. I will need to try this again. Let's say it gives me 9.95. Okay, so I will sum this together and divide by 2 to get the actual value. All right, to get the actual value. So after performing this for 150 grams, I will need to repeat this particular process for 200 grams. So I'll add an extra 50 to make it 200 grams and displace vertically and take the time to perform 20 or maybe 10 oscillations based on what is given. All right, so I'm still going to record that in my table of values. Okay, so same thing, right? So this is basically what experiment 1 is all about. Simple harmonic motion. Now it's also very important that whilst you are trying to carry out the practical given to you, you need to know some fundamental theory behind the practical. Well, this is basically the theory under the period of a loaded spring. As you can see, the spring has been loaded with a mass. All right, now the period of a loaded spring is given as 2 pi square root of m over k, where m here is the mass attached to that spring and k here is the force constant. Okay, so most likely after performing this experiment, you will be told to draw a graph of allow me to use this space. I love using my space very well. Okay, to draw a graph of t squared against m. When you say draw a graph of t squared against m, it actually means t squared on the vertical y-axis and m, which is the mass, on the horizontal x-axis. Now, if I'm to represent this, let's look here. I will square both sides. My marker is out. I'll square both sides. I hope you are seeing this. So this will be 4 pi squared. If I square both sides, m over k. All right. So if I solve the maths here, this will give me t squared over m, and that I'll be left with 4 pi squared over k. Okay. So drawing a graph of t squared against m, the slope in this case will be equal to 4 pi squared over k. So the whole idea of this experiment is to determine the force constant of the identical springs that you are using. That is what I mentioned earlier, that these 2 springs must be identical. All right, so the whole idea of this experiment is to help us obtain a value for the force constant of the spring that you'll be using. All right, so this is just what the experiment is all about. Like I said, this is just a prediction, and I feel like 70%, 75, 80%, it will likely be in this direction. Okay, it will likely be in this direction. I'm still going to show you how this is done in real time, just that I am not in the lab currently. Okay, so I'll be posting that video on how you can carry out this particular experiment. Like I mentioned, this is just one of 4 experiments. All right, so thank you very much for staying true. Please click on the notification button because I'll be dropping the practical perspective of this video. Thanks for watching. If you have not subscribed yet, do well to subscribe. You know why? Because physics is made easy here in this YouTube channel, Physics with Paulamin. Thank you.